All right, so here we have a more complicated circuit. The thing that stands out right away is two batteries on different branches, right? And I know I said this already before I started recording, but let me say it for the recording. If you have two batteries on the same branch, that's no big deal at all. Like two batteries right there. Let's say you got 5 volt and 8 volts, like that. A 5 volt and an 8 volt would simplify to a 13 volt. Now, what if the batteries were not arranged the same way? So for example, like what if the 5 volt battery were like this? Okay, what's going to win here? The 5 volt battery is pushing the current to the left. The 8 volt battery is pushing the current to the right. So which battery is going to win? The 8 volt. So this situation up here would simplify down to a 3 volt pushing the current to the right. Okay. Now in this problem here, example 6 from the lecture notes, we definitely have a trickier situation because we have two batteries on different branches. Those batteries are in parallel. So what the problem wants us to do is find the current in each branch of the circuit. So we have 3 different currents here. All right, so look, let's start by labeling the currents. This 20 volt battery is pushing the current that way. Let's call this I1. So I1 goes like this. Okay, now this 10 volt battery is pushing the current this way. So let's call this I2. Now I2 comes in right here. At this junction right there, I1 and I2 come together to form I3. So I3 goes around like this. Comes up like this. What current's right here? That's I1. Okay, so we've labeled the currents. Now look, the way you solve a problem like this, you use what's called Kirchhoff's rules. Kirchhoff's rules, it's 2 rules. The first rule is called the Junction Rule. And we've already talked about this, but we haven't called it that. The Junction Rule basically says the current into a junction equals the current out of a junction. So let's look at this junction right here. What are the currents coming into this junction? I1 plus I2 must add up to what? I3. Current coming in equals current coming out. I mean, you could have focused on this junction over here. Look at what's happening over here. Well, what current's coming in? I3. What current's going out? I1 and I2. So you get the same equation. So that's the junction rule. We made an equation from the junction rule. Okay? Now, the other rule is the loop rule. Okay? The loop rule says this: for any complete loop, voltage gain equals voltage loss. And we've talked about that too. Voltage gain equals voltage loss. So how many possible loops do we have in this circuit? There are 3. What are the 3 possible loops? Well, the first possible loop is the outer perimeter. We could loop the outer perimeter. What else could we loop? We could loop the top. That's the second possible loop. And then there's the bottom. Okay? Now voltage gain equals voltage loss. Okay, so let's just do it. So I'm going to loop the whole outer perimeter first. So let's start right here. Okay, ready? So we're going to loop around. Now what's happening when we cross this first thing right here? Voltage gain or voltage loss? We're going from negative terminal to positive terminal. That's a what? A gain. So 20. Okay, now we're crossing this resistor. Voltage gain or voltage loss? Loss. What is the voltage loss? Well, let's use Ohm's law. Delta V equals IR. So that's going to be minus I1 times 30. So let's put that a little nicer. Let's go 30 I1. That's just Ohm's law, right? So that's minus 30 I1. You guys get it? Delta V equals IR. Okay, let's keep looping. Ready? Loop, 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 loop. Okay, bam. What's happening right here? Voltage gain or voltage loss? loss. Delta V equals IR, so that's going to be 20 times I3, so that's minus 20 I3. Okay, let's keep looping. Bam, we're back to the starting point. So what must this be equal to? If voltage gain equals voltage loss, what's this going to equal? 0. We just wrote an equation. Okay, let's do another loop. Let's loop the top. Okay, let's loop the top here. Okay, so starting at this point again. Okay, so we're going. We're crossing the 20 volt battery. Voltage gain or voltage loss? Gain. We're going from negative plate to positive plate. All right, we're crossing the 30. Voltage gain or voltage loss? Loss. That's going to be minus 30 I1, right? Okay, now come down here. Now, boom. Now, guys, you got to pay attention here. We are crossing, so I'm looping this top part. I'm crossing the resistor, this 5 ohm guy, against the current. Voltage gain or voltage loss? Gain, because we're crossing it against the current, right? So this is going to be plus 5I2, just using Ohm's law here, right? If we were going with the current, then it's a voltage loss. Okay, now we come to a 10 volt battery. We're crossing it from positive plate to negative plate. Voltage gain or voltage loss? Loss. That's minus 10. And then we're back to the starting point. That equals 0. Okay, so guys, we have 3 equations and 3 unknowns. Is it solvable? Yeah. If you have 3 unknowns, what are the 3 things we're looking for? We're looking for I1, I2, and I3. We got 1 equation, 2 equations, 3 equations. You can substitute those together and solve for the 3 currents. Answers are up here. Okay?